Good day. In this video, we're going to talk about area and perimeter. So let's start with the very basic. So you have to know the areas. So I'll show you something. So you have to know the areas of the four basic shapes. So the area of a square, the area of a rectangle, the area of a triangle, and the area of a circle. So by the way, a square is also a rectangle because the requirement for something to be a rectangle is that opposite sides must be equal. So opposite sides must be equal, and a rectangle has opposite sides are equal. But now when you look at a square, also a square fulfills that opposite sides are equal. The only thing is that a square is special in that all sides are equal this time. So a square is a rectangle, but it's a special type of rectangle. It's a special type of rectangle because in a square, all sides are equal. But a square also fulfills that. A square fulfills the fact that opposite sides are equal. This side is equals to this side, and this side is also equals to this side. So a square is a rectangle, but it's a special type of rectangle. So the area of a square is the same as the area of a rectangle, because in a rectangle, the area of a rectangle is length times breadth. But in a square, it's also length times breadth. But because the sides are equal, we just say it's side times side. So what about the area of a triangle? The area of a triangle, let's call this the base, and let's call this the perpendicular height. So the area of a triangle is half of the base times the perpendicular height. And then the area of a circle. So the area of a circle, if this be the radius, the area of a circle is pi r squared. So let's just do very few examples, then I move on to the next level. Then afterwards, we'll talk about perimeter. So there are different levels that we'll attempt. For instance, you need to know how to attempt this type of level. For instance, we've got a semicircle on top of a rectangle, and if they ask you for the area of this portion, you should be able to determine that. But for now, let's start from the basics. So after here, we'll now go to the perimeter. Perimeter is also important, and it often complicates students even until grade 12. So we'll deal with some examples. So let's just deal with just a simple example. Let's just say you're told that this is a square and this is 20 centimeters. Well, if they ask for the area of a square, you know that the area of a square is length times breadth, right? Or side times side. So since it's a square, it means all sides are 20 centimeters. So it just means it's going to be 20 times 20, which is 400. So we're just going to have 400 centimeters, but centimeters squared. So every time we write area, it has to be centimeters squared. What if they don't give you centimeters or meters? If they don't give you anything, you will just say units squared. So you'll just say units squared. So this is very simple, not difficult at all. So now let's talk about, let me just give you another example. Let's just say we've got something like this. So I'm just starting from the basics. I will move on to a higher level. So let's just say we're told that this is a rectangle, and we're told that this is 20 and this is 10. Well, we know that the area of a rectangle is length times breadth. So it just means the length is 20 and the breadth is 10. So it just means it's going to be 200. So we're going to have 200. And because they didn't give us any units, we'll say units squared. If they gave us meters, we'll say meters squared. So that is how it is. And let's just go to another example. So after 2 more examples, I move on to a higher level. So let's just talk about the triangle. Let's just say we're told that this is the perpendicular height, and let's just say we're given, let's just say, so with the triangle, I'll show you 3 examples for some reason. So let's just say we're told that this is 10 centimeters. So centimeters, that's the perpendicular height. So let's just say we're told that the perpendicular height is 10 centimeters, and we're told that this space is 20 centimeters. So obviously the area of a triangle is half of the base times the height. So we'll just say half of the base. The base is 20 times the height, which is 10. So 20 times 10, or if you want, half of 20 is 10, and 10 times 10 is 100. So it means it's 100 centimeters squared. So it is very simple. Now let's go to a second example. So let's just say you're given something like this. Let's just say you're told that this side is 10 units and this side is 5 units. And let's just say you're told that, okay, matter of fact, let me change this. Let's just say this is 16 units and let's say this is 10 units. Matter of fact, let's just call this 8 units. And let's say this side you're told that it is 20 units. So if they ask you for the area of this triangle, it is half of the base times the perpendicular height. So already we know the base is 16 plus 8, which is 24 units. So you are told that this part, is 16 and this part is 8, so we know it's 24, but we've got a problem. We don't know the perpendicular height. Well, what you'll do is that you'll use Pythagoras theorem because it's a right angle triangle. So in this specific triangle, we've got this length as 16, we've got this one as 20. We need to get this. So in order to get this, we know that c squared is equals to a squared plus b squared. There is a shorter way to use it, but I'm just going to use the long way. So c will represent the hypotenuse. So the hypotenuse is 20 squared, and then we're going to have the well-known side, and then we're going to have plus b squared. And then from there, we're going to end up having 400 is equals to, I believe it's 256, so b squared. And then now we're going to have 400 minus 256. Alright, so now we have to figure out what is that. So that is going to give you 144. 144 is equals to b squared, and when we square root both sides, it's going to be 12 is equals to b. So we found the perpendicular height, which is 12. So let me just erase this stuff. So we're given that the perpendicular height is 12. So now we can find the area of the triangle. So the area is half of the base times the perpendicular height. So half of the base, which was 24, times the height, which is 12. Alright, so now I'm going to do it this way. Yep, half of 24 is 12. 12 times 12 is 144. So it means the area is 144 centimeters squared. Yep, so we found the area of that specific triangle. So let's just go to the last example of triangles. Then I go to circle. So let me just erase this stuff for just a second or two. So let's just say we've got something like this. Okay, let's just say we've got something like this. So if we're told that this is an isosceles triangle and we're told that this is 10 units, let's just say we're given that this side is, let's just say it is 6 units. Okay, matter of fact, let's make it 12 units. So if we want to find the area of this triangle, it's going to be half of the base times the perpendicular height. The problem is that we don't have the perpendicular height. So sometimes you can have an obtuse angle triangle and you are given the perpendicular height. So you will just simply say half of the base. If the base was 10, if this is 10, you just say half of 10 times the perpendicular height. Maybe you are given that is 2. So it's just going to be half of 10 times 2. And then that's going to be equals to 10 units squared. But now here, we are not given a perpendicular height. So what will you do? So you're told that this is equals to this stuff, and you're not given a perpendicular height. Now, if it's an isosceles triangle, you already know that this side is also 10. But we've got a problem. We need the height. So what you'll do is that whenever it's an isosceles triangle, if you draw a vertical line, that vertical line will actually cut this into 2 equal parts. It doesn't happen in every triangle. In some triangles, we've got something like this. If we draw a triangle, let's just say we draw a triangle. If we construct a perpendicular height, notice, so if you construct a perpendicular height, it does not divide this into 2 equal parts, simply because this side is not equal to this side. So only when the 2 sides are equal, so whenever these 2 sides are equal, that's when it will divide this into 2 equal parts. So from here, if this is 12 units, it means this is going to be 6 and 6. So now we can find the perpendicular height. So then it means that we can use any triangle we want, either this triangle or this triangle. So let's just use the first one. So then we're going to have 6 here and we're going to have 10. So we know according to Pythagoras theorem is c squared is equals to a squared plus b squared, and then c is 10, so it's going to be 10 squared is equals to 6 squared. So 6 squared plus the unknown side, so yep, so 6 squared plus b squared. So then this is going to be 100 is equals to 36. So we're going to have 36, so plus b squared. Then we're going to have 100 minus 36 equals to b squared. And then from here, it's going to be 64 equals to b squared. And then from here, when we square root both sides, it means that b is equals to 8. So we found the perpendicular height. So the perpendicular height is 8. Now we can find the area of this triangle. So the area of this triangle is half of the base times the height. So half of the base times the height. And then from here it's going to be half of 12, which was the base, times the height, half of 12 times 8. So, okay, fine, half of 12 times 8. So then this is going to be, should be 48. So since it's area, we're going to say units squared. All right, finally, let's go to the circle. Then let's go to the area of the circle. Then we'll go to the higher level. So let's just do the basics of area of the circle, because the circle is very important. All right, let's talk about the area of a circle. So let's just say we've got something like this. Let's just say the radius is 12, or let's just say the radius is 10. So the area of a circle is pi r squared. So now we're going to have pi r, so the radius is just 10, so we're going to have 10 squared. So if you type in the calculator, you'll have 100 pi. And then if you type SD, you'll get it in decimal places. So I am not using a calculator, so I'll just leave it like that for now. So sometimes you are not given the radius, sometimes you are given a diameter. So if the diameter is 20, you simply say the radius is half of the diameter. So then it just means that we're just going to say the same thing. It's just going to be pi 10 squared. And this is 100 pi. All right, now let's just move to something. Just one more thing. So sometimes you are given something like this. If you are given a semicircle is half of the circle. So if you want to find the radius, if you are given, let's just say we have something like 20. If you want to find the area of the hemisphere, the area is how much space something occupies. So if you want to find the area, all you'll do is to just say that here we know, since it's a diameter, we know it's just going to be 10 as the radius, and then it's going to be pi r squared. So the formula will be pi r squared, but you'll divide it by 2 because it is half. So it's just going to be pi times 10 squared over 2. So over 2. Then that means we're going to have 50 pi. Yep, so that's how it is. So now let's talk about combinations of shapes. Then I go to perimeters. So sometimes we can have something like this. Let's just say we've got something like this. Matter of fact, let's just say we've got an ice cream cone. Let's just say an upside down ice cream cone in a way. So if you are told, so let's just say you're told that this is 20 centimeters. And you are given that this is an isosceles triangle, and you are told that this is 10, or rather, let's just make it, let me just plan, well, okay, fine. Matter of fact, let me just change this 20. Let's make it 16. All right, and then let's just make this 10. So this is all you're given, and you're asked to find the area of this part. So in order to find the area of combination of shapes, you just have to find the area of this part and then add it with the area of this part. So let's find the area of this part first. So in this part, the area of a triangle is half of the base times the height. So we do have the base, but we do not have the perpendicular height. So what do? At times we use Pythagoras theorem, but How are we going to use Pythagoras theorem? Remember, this is an isosceles triangle. So if you have an isosceles triangle, it means whenever you draw a vertical line, it will cut this exactly into 2 equal parts. So therefore, it means that this is going to be 8 and 8. So now we can use the triangle. So we've got 10, we've got 8, so we can find this side. So then it means it's going to be c squared is equals to a squared plus b squared. And then the hypotenuse, which is 10. So 10 squared is equals to 8 squared plus b squared. And then this is going to be 100 is equals to 64 plus b squared. And then from here, we're going to have 100 minus 64 equals to b squared. And then 36 equals to b squared. And then b is equals to 6 when you square root both sides. Okay, when you square root both sides, you'll have b is equals to 6. So that's what we have. So it means we found the perpendicular height as 6. So from here, we can now find the area. So we can find the area of this triangle. So it means area is half. So half of the base. The base is 16 times the height, which is 6. So this part is going to give you 48. So we have 48 units squared. And then now we have to find the area of this semicircle. So we already know that this is a diameter at the same time, because in this particular portion, you are given this length, which is the diameter. So from circumference to circumference is a diameter. So when it passes through the center. So you are given this as 16. So the radius is 8 because it's half the diameter. And we have just figured out that here, same thing. So it means that it's going to be pi r squared over 2 because it's a semicircle. So it's half of the circle. So it means that we're going to say pi r is 8 over 2. So it means that it's going to be 36 pi. So it means we're going to add these two. We have to add the area of this and the area of this because we've got a combination of two shapes. So it's going to be 48 plus 36 pi. Yep, when you type that in the calculator, you will have your exact answer. Alright, let me just erase this stuff and let's go to another one. So sometimes we do not have a combination of two shapes. Okay, let's deal with one combination of two shapes first. So sometimes we have something like this. Let's just say we've got something like this. So you are given a weird shape. Let's just say you are given a weird shape and you're told that this side is the same as this side. And this is perpendicular, and let's just say you're told that this is 10 units. And let's say this side is 5 units. Alright, so we know that this is gonna be, and this is a semicircle. So we know that it's gonna be a triangle, a square, and a circle. So if they ask you to find the area of this portion, let's find the area of the triangle. So we know that the area of the triangle is half of the base times the height. So it's gonna be half of the base. The base is 10 units. The perpendicular height, since it's a rectangle, this side is the same as this side. So this length is the same as this length because it's a rectangle. In a rectangle, opposite sides are equal. So it means that this is also 5. So half of 10 times 5. So it means it's going to be 25. That's the area of the triangle. So we found it as 25. Now let's find the area of this portion. Well, we're told that this side is the same as this side, meaning that this is also 10. The area of the rectangle is length times breadth. So we're just going to say 5 times 10, and that is 50. Yep, so we found the area of this portion as 50. Now let's find the area of that part. That is a semicircle. So since it's a semicircle, it means that, well, we have a diameter because it's the same as this part. So it means this is 10, meaning that the radius is 5. So we have 5. Now we're going to get the area. So the area is pi r squared, but divided by 2 since it's a semicircle. So it means it's going to be pi 5 squared divided by 2. So it means it's gonna be 25 over 2 pi. Yep, which is, yeah, so it means it's gonna be 25 over 2 pi. So when you add these three answers together, you have your area. So that is how it is. Now let's just go to perimeter. So perimeter often confuses people when it comes to shapes that are not as normal. So this is the area. So let's deal with the perimeter. So let me just erase this stuff. So the perimeter, let's just start with a square. So we know that the perimeter is the sum of all the sides. It's when we add all the sides together. So if this is 10 and they say find the perimeter, it means it's just gonna be 10 plus 10, because we're gonna add this, we're gonna add this, we're gonna add this, because it has got 4 sides. So plus 10, which is 40, or you can simply say 4 times 10. So you can simply say 4 times 10. And then now here, let me just go to another stuff. So let's just say what all that this is. Let's just deal with the triangle. So let's just say we're given that this is, let's just say this is 16. So if this is 16 and we're given the perpendicular height as, let's say 6. Yep. And then you're asked to find the perimeter. Well, in order to find the perimeter, and let's just say this is an isosceles triangle, we know that this is going to divide this into 2 equal parts. So it means that this is going to be 8 and 8. So we can use Pythagoras theorem to find this side, because we need to add this and this. Because for us to find the perimeter, how many sides are there? There's 1, 2, 3 sides. So we need to add all 3 sides. We need to know their sizes, and then we have to add them. So we can use Pythagoras theorem, and then this is gonna be 8, and then this is gonna be 6. So we can find the hypotenuse. So it means c squared is equals to a squared plus b squared, and then c squared is gonna be equals to 6 squared plus 8 squared, and then this 36 plus 64, and this gives us 100. So c squared is equals to 100, and then if you square root both sides, you will have c is equals to 10. So if this side is 10, we don't need to do the whole calculation again for this side, because we're told it's equal. So it means it's also 10. So that is 10 units. But what? Let me just erase this stuff, so then we can easily find the perimeter. So it means the perimeter will be 10 plus 10 plus 16, because we're having 10, 10, and 16. So it means that it's gonna be 36. So that is the perimeter. So the perimeter is 1 dimension. We'll just say units. If it's centimeters, so it won't be units squared. For areas, units squared, but for perimeter, it's just units. If you're told that it's centimeters, you'll just say centimeters. So if you're told that it's centimeters, you'll just say centimeters. So you won't say centimeters squared. So you'll just say centimeters. But if you're not given any scale of measurements, you'll just say units. So let's just go further. So let me just erase this stuff, and then let's talk about the perimeter of a circle. So the perimeter of a circle, you see, you notice that the area of a circle is pi r squared, but the perimeter of a circle is 2 pi r. You have to claim this, you have to memorize this. So for instance, if I'm given that the diameter is 10 units, then we already know that the radius is half of the diameter, meaning that there's going to be 5 and 5. So if you want to find the perimeter of a circle, which is the same as this whole round stuff, imagine if this was a rope, and if you cut this part and you stretch it, the length of this stuff will actually be 2 pi r. So the perimeter of a circle is 2 pi r. So if you want to find that, it means it's going to be 2 pi, and our radius is 5. So we just want to say 5. Then this is going to give you 10 pi. You can type S in the calculator, you'll be able to round out to decimal places. Yep, so that is 10 pi. So now we've got a slight problem. Now from here, let's move to another level. We've got a slight problem, something that bothers people. For instance, what about the perimeter of this stuff? It's a semicircle. So how many sides do we have? We've got 1 and then we've got 2. So we have to find the length of this, then we have to find the length of this. So let's just say this is 10. So if this is 10 centimeters and we have to find the length of this stuff, it means that we're gonna say this is already 10, but now we need to find the length of that stuff. So notice this is supposed to be a complete circle, so it's half of it. So the circumference of the circle is 2 pi r, but now we're gonna divide it by 2. So this is just the same as pi r, or if you want, you can just leave it as 2 pi r divided by 2. So it's gonna be 2 pi, and our radius, this is 10 centimeters, meaning that is 5. So it means it's gonna be 5. So it means it's gonna be not r squared, I made a mistake, it's just 2 pi r. Yep, so it means it's gonna be this stuff, and then here we're gonna have our answer as 5 pi. So that is the length of this part. So this part is 5 pi, so we have to add it with this part. So then it means it's gonna be 5 pi plus 10, and then you type this in a calculator, you'll get your answers. Let's just go to another stuff. Let's just go to another thing. Okay, let's just go to another thing. So let me just erase this stuff. Alright, let's just say we've got something like this. So let's say we're given a rectangle and this stuff. So this is a rectangle, and let's say you're told that this part is 20. And then let's just say you're given, let's just say you're given this stuff. Let's say you're given this stuff as 16. And let's say you're given this stuff. So let's just say from here to here is 16. So this portion is 16, and you're told that this is, let's call this 3. So the perpendicular height is 3. And from here, yep, let's just say that is all you're given. Okay, fine. This is not a realistic diagram, but let's just say you're told that this is, let's say you're told that this is 15. So if they ask you for the perimeter, okay, let me just see if I can change something. Nope, it's not gonna work. Okay, fine. So let's just say you're given this stuff and you're asked to find the perimeter. So how many sides do we have? We've got 1, 2, 3, 4, 5. So we have to we have to have the length of all 5 sides, and we have to add them. Notice I always count the sides because it's helpful to count the sides. Sometimes if you don't count the sides, for instance, a lot of people make mistakes here. They will if they asked for an area of a semicircle, they will only add this part and forget this because they did not count. So you have to count the sides. You have to know how many sides are there. So there are 5 sides, and we have to have the length of all the sides. So we don't have the length of this side, but we do have, it's a rectangle. So if it's a rectangle, it means this part is the same as this part. So therefore, it means that this is also 10. And then now we need this part. So how do we get this part? Well, in this particular triangle, if we can use Pythagoras theorem, we can get it. But we have a problem. What is the length of this side? We have got this side, but we don't have this side. Well, we have this side because we're told that this is 20 units. If this is 20 units, this is also 20 units. Then it means that this portion is just 20 minus 16. So this is going to be 4 units. Then we can use Pythagoras theorem to find that. So c squared is equals to a squared plus b squared. Okay, let me just write it better. So it's going to be equals to a squared plus b squared, and then c squared is the hypotenuse, is what we're looking for. So we're going to have 4 squared plus 3 squared. So then 4 squared is 16, 3 squared is 9, then we're going to have 25 is equals to c squared. Then when we square root both sides, we're going to have c is equals to 5. So we found it. We found the value of See, we found the hypotenuse. So the hypotenuse is equals to 5. So we're going to have 5 here. Yep. Now we can find the perimeter. So the perimeter is just this plus this plus this plus this plus this. Notice I did not add the one inside. You only consider the ones that are outside. So just picture it as though it was a fence. So let's just add them. So we're going to have 15 plus 5 plus 10 plus 20 plus 10. 15 plus 5 is 20 plus 10 is 30 plus 20 is 50 plus 10, 60. So there we have it, 60 units. Yep. So this brings us to the end of the video. So that is perimeter and area. So for instance, sometimes you could have a shape like this. If you're asked to find the perimeter, you have to know this side, this side, this side, this side, and this side. If you can find all of them, then you have found the perimeter. Yep. So that is just it. Alright, if you like this video, please like the video and subscribe to my channel. Any questions you have or any video you want me to make, comment below. See you in the next video.